linear equations in 3 dimensions. So we will graph points and linear equations in 3 dimensions. But what really is linear? It's not what we may think. It's not just y equals mx plus b. Remember that linear means in general that you have no variables multiplied together and no variable with an exponent different than 1. So that will allow us to have, well, 3 variables. What is that? It's a line in 3 dimensions. Not exactly. It's actually a plane. And we'll get to that in a little bit. But I first want to start off by graphing ordered triples. So instead of ordered pairs of just x, y, we now have a third component of z. The x, y, and z axes intersect in 90-degree angles. And this is the space in which we live and in which our brains are wired to navigate. So you will be provided with a 2-dimensional graph, and it is then your goal to then, at a 45-degree angle, construct the third axis. Remember, these intersect at 90-degree angles, here and here, and then this would then technically also intersect at 90-degree angles, like so. The interesting thing about how I'm going to do this is instead of having the traditional x and y and then z coming out of the page, which you could totally do if you want, I'm going to switch it up because you can. You could just make the grid whatever you want. You could place it wherever you want on a real-world object that you're trying to study. Like if you're talking about some sort of projectile, you don't want to start, probably the origin is going to be the beginning of that projectile's motion. So here I'm going to put the x as the one that comes out of the page and through the page. And then the y is going to be the horizontal one, and then the z axis is going to be vertical. So jumping into the first problem, I have some color coding here to help us track the point because it's 3-dimensional space. So I'm going to let the first coordinate of x be red, the second coordinate of y be blue, and the z coordinate green. So it helps to kind of leave a breadcrumb trail of how you progress from the origin to your point. For point A, I travel 3 in the x direction, 1, 2, 3. So notice I go 3 diagonals. And that's just going to be the best that I could do. I know the diagonal length is longer than the side length of the squares in the grid, but we get the idea. And then from there, so by the way, this is positive x up here, and this is negative x here. So when you go away from yourself, then like as if this x-axis is going through the page, that's negative, and then when it's coming out or towards you, that's positive. And then of course this is y plus, y minus, z plus, z minus, like the usual orientations. From here, I then go in the -2 in the y direction from where I left off. So 1, 2, and then I go up in the z direction 1. And that's where I plot my point. So I plot there and label it A. So it came forward 3, left 2, up 1. Doing the same thing for the next point. I'm going to use red for the x of 3. I'm sorry, in this case for b is 2. So I go 1, 2, overlapping where I just was. I make a left-hand turn. So that is going to be blue for y. So I go here, and then green down, z of 3, 1, 2, 3. And I'll label that point as B. So before I move on, let's kind of think about this in terms of quadrants. It's going to be a little tricky, but kind of this upper right-hand space is one, well, let's see here. I have 1, 2, 3, 4. I have a total of 8 different regions. So this one here is front, lower left, where B is, and A is going to be like toward me and then upper left. So try to visualize that. I know it's difficult. So let's plot that final point of C. So I start off going -1 in the x direction. So now I go back through the page. And then I don't go any in the y direction. It's 0. So then I stay on the x-axis and have no horizontal or left to right motion. And then I go up 2 for z. And plot that point. And that is going to be between 2 of the regions. So it's going to be back, upper right, and back, upper left, right on their boundary. And that is point C. Remember, you could label your axes however you would like, as long as you are plotting correctly. And I recommend using the breadcrumb trail so that it kind of helps with the whole perspective issue, since this is actually a two-dimensional space and we're using perspective drawing here. So now let's move into graphing a linear equation in 3 dimensions, which forms a plane. And the trick here is to find 3 points, because 3 points define a plane just as much as it does a triangle, and that's why the triangle is the most sturdy shape in 3 dimensions. If you think about it, it makes sense. So here, pardon the interruption, so we want to graph using intercepts. So we have an x, a y, and a z-intercept because we have the 3 axes. So, I don't know, this time I could switch up my axes, but I'll be consistent. I'll let that one x, this one y, this one z. Go however you would like. I'll use red for the x-intercept again. So that means that not only y will be 0 on the x-axis, but also z will be 0 on the x-axis. So I substitute in zeros for those other values. You could just opt not to write them. And then I solve the resulting one variable equation. Beware. X equaling 3, you do not want to think about that as like a line at 3 that's vertical. I just found an intercept. So what that means is an ordered triple. So I recommend that you then put together the 2 inputs of 0 for y and z with the result of x all together so you don't make that mistake. And if I plot that, then it's 1, 2, 3. Okay, I don't need to do breadcrumb trails, so I just go 1, 2, 3 and plot that point. So that's coming out of the page at me, staying on the x-axis. Now I will find the y-intercept. So I substitute in zeros for the other variables because it's all about the y, so then I don't care what the other variables are doing. So I could just mark that off, and I get -3y is equal to -6. And I mark those off because I'm substituting in 0, and multiplying with 0 will give me just 0. So then I get y is equal to 2. So then I plot that. Remember, that is an ordered triple, 0, 2, 0. And that is going to be in the direction to the right, right here. And I do the same thing for z. So the z-intercept, substitute in 0 for the others, so then they just go away. Multiplying out to 0, so z is equal to -6. So I go down 6. 1, 2, 3, 4. You get the idea. 2, 3, 4, 5, 6. Right about there. And then from here, it's kind of tricky. You need to be able to visualize the plane. drawing it is just a nightmare, so I will just require that we put dashed lines between them, because then it kind of shows that we have a triangle, but not just a triangle. And if you look online and in our textbook, then you could see better graphics done using technology. And hopefully you could picture that the plane is kind of coming at an angle that's in the front lower right, but then remember it does extend infinitely in all directions because it is a plane. So that's it on graphing in three-dimensional space, ordered triples, and linear equations, which are planes, because they have three variables. You could have a linear equation like x plus y equals 5 in 3 dimensions, and that would just be a line, but we also had to account for the z variable's effect on our graph. So let's apply this a little bit, and we have a track team. They score 5 points for finishing first, 3 for second, 1 for third. The team scored a total of 30 points. So write a linear equation in 3 variables to represent this situation. So we have, I'm going to just say F for first, S for second, T for third. You could use X, Y, Z. So it's 5 for first, 3 for second, and 1 for T, for a total of 30 points. So they finished second in 6 events. Third in 2 events. How many events did our team finish first? So you do the arithmetic and find that the answer is 2. Lynn's team took first twice. So the main thrust is to remember that in 3-dimensional space, you have an x, y, and z dimension. Those axes intersect at 90-degree angles, and you get to choose what you label the axis that comes out of the page and through the page. And then remember, going through the page, though, I would probably keep that negative. But hey, if you feel like going forward means positive, then by all means, just clearly label. I have this subscript here showing negative, this superscript rather, showing positive. When you go to 3-dimensional space, be very careful to make these ordered triples after you find the intersections, the intercepts, so that you're only plotting a single point.